Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section I am going to discuss about the derivation of integrated rate equation for the rate constant of zero order reaction. Okay, this topic is from chemical kinetics lesson 2nd PUC Nana. Okay, so first I am considering one general equation. Students, consider A gives rise to products. Okay na, consider A gives rise to products, or we can take it as, or also we can take nana. So I'm taking as R only. I'm taking reactants gives the products. Okay, consider one reaction, reactants gives the products. Now I'm going to calculate the rate. So we know that rate is directly proportional to the product of the concentrations of the reactants, correct? That means it is directly proportional to the concentration of the reactant. Are you understanding? The reactant is R, it is directly proportional to Rm. But it is a zero order reaction now, so that's why I'm taking in the power 0. Are you clear? In the first order reaction I am taking here 1 anamata. Okay na, 1. In this case I am taking 0 order reaction, power is 0 because its order is 0. Okay na. Now anything to the power of 0, how much students? 1. So R power 0 value 1. Okay, from this one what we can write? Proportionality constant K into R naught. So this is the square bracket indicates what, students? Square bracket indicates concentration R naught. So anything to the power of 0, 1. So R value how much, students? K into R power 0, 1. R is equal to K into 1, R equal to K. This is the first equation, students. Clear, Nana? Now see, students, in another case we know that rate is equal to, we can write minus dr by dt. Minus indicates the decrease in the concentration of reactants. We know that in any chemical reaction generally the reactants concentration gradually decreases and product concentration gradually increases, students. Correct, Nama? So that's a reactants concentration decreases na, that's why I'm taking the sign minus d of r by dt. D indicates the small change. Okay na, this is the concentration. Square bracket indicates concentration. So change in the concentration of reactants by change in time. Adhaitama. So R is equal to minus dr by dt. Clear? So minus dr by dt, this is the second equation. Okay, from equations 1 and 2 what we can write, students? From equations 1 and 2, left hand side LHS, so here LHS, so R only. So that's why right hand side, so LHS part both are same nama. Now RHS part you take, students. K is equal to minus dr by dt. So what we can write? K is equal to minus dr by dt nana. So here I am taking as R's one place and K into dt one place I am taking, students, one side. So d of R is equal to minus K into dt nana. Minus K into dt. Clear? dr is equal to minus K into dt. Now integration on both sides. Integration on both sides. Now when we are doing integration on both sides, students, see here integration of d of r is equal to minus k into integration of dt. Minus k into integration of dt. Clear, Nana? dr is equal to minus k into dt. So integration of d of r is equal to minus k into integration dt. Here this is constant na, that's why I am taking separately. Okay, and outside minus k into dt. So we know that one formula, integration of dx is equal to x, correct? Integration of dx is equal to x. Okay, now see, students, after this, so integration of d of r is equal to how much, nana? R is equal to minus k into integration of dt value t plus integration constant I nana. Okay na, minus kt plus I. Now I want to calculate I value, students, integration constant. So that's why to calculate I value, nana, I am taking at t equal to 0. Initially, nana, T equal to 0 means the final concentration of the reactant is equal to the initial concentration of the reactant at T equal to 0. That means R equal to R naught. Understood, Amma? Initially. So this value R equal to R naught, T value 0, substitute in this equation. Now R equal to R naught now. So that's why these values, okay now. So suppose I am taking, this is the equation A, this is B. Now substitute B in equation A. Okay, Nama? Substitute equation B in equation A. Now substitute, students, R value R naught, T value 0. So R value R naught is equal to minus KT, minus K into T value how much, Nana? 0 plus I. So how much, students? R naught is equal to 0 plus I. Then I value how much, students? 0 plus I. And then I value how much? I is equal to R naught. Clear? This I am taking as C. I is equal to R naught. So I value calculated. Now this value substitute in the equation A. Okay, Nama? So C equation substitute. Now substitute equation C in equation A. Now substitute, students, in equation A. R is equal to minus KT plus I. Okay, I value how much, Nana? R naught. So minus KT plus I value R naught. Okay, now minus KT plus R naught. Understood, students? Minus KT plus R naught. Then how much you will get, students, from this one? KT is equal to, it is in the right hand side, it is coming to left hand side. That means minus will become plus. KT is equal to R naught minus R. Then K is equal to how much, students? R naught minus R by T. Understood, Amma? So R naught minus R by T. This is the rate constant for the zero order reaction, students. K is equal to R naught minus R by T. R naught minus R by T. This is the rate constant. Okay. Now we have to find the T half value. Okay, Nama? T half value also we have to find. And before that, I am going to discuss the graph. Now see, students, graph from which one I am taking equation? Which equation? This one. Okay, just I am giving this also numbering. This is a third equation. Okay, third equation. Now see, students, from the equation 3, what we can write? Now see, from equation 3, R is equal to minus KT plus R naught. Kada? R is equal to minus KT plus R naught. It is in the form of Y is equal to MX plus C form. Correct? Now along this, now see, students, graph Y is equal to MX plus C graph is, will get like this. Yes, Nama? Y is equal to MX plus C graph. Now Y, in Y place which one is there, students? R is there. Correct? R. So that's why along y-axis I am taking R. Okay, Nama? Next, along x-axis. In x place what is there? T is there. So that's why along x-axis time I am taking. And what is the slope, students? Slope is equal to how much? M is equal to minus K. So M is equal to minus K. And what is C, students? It is the y-intercept. What is this? Y-intercept. Now what is intercept, students? This line where touches or where cuts the y-axis, that is called, where touches the y-axis is called y-intercept. How much, students? C value y-intercept? R naught. So this point is R naught. Clear, Nana? Okay, now. So this is in the form of Y is equal to mx plus C. Along y-axis concentration of the reactant, x-axis time, and what is the slope? M is equal to minus K. And what is y-intercept? It, when it is touches the y-axis, that is calling as y-intercept R naught. Clear this one? So this is the graph, students. Okay, Nama? So next I am going to calculate the T half life. Understood? So what is the half life? See, students, half life, how to find it? Half life, how to represent this one? T half. Okay, na? T half life. What is half life, students? The time is required for the completion of 50% of the reaction. That means the time is required. The time the time is required to complete the half of the equation, half of the reaction. Okay namma. So that means the time is required to complete the half of the reaction. That means, for example, a reactant gives the product, students. Okay na. So that means a is 100% initially. That means to become this concentration, okay na, it is initially at t equal to 0, at t equal to t half. Okay na. At t equal to t half, this concentration should become 50 percentage. Are you following? That means to complete the half of the reaction, half means in 100 how much, students? Half of 50%. To complete the half of the reaction, how much time is required? That is nothing but half life. Clear, students? First, initially a is 100%. To complete this half of the reaction, that means to become half. Okay, that means 50%. That is how much time is required. That means concentration A is maximum initially. By increasing time of the reaction, the reactant concentration is decreases kana. It is decreases to that means 100 to 50% means to become half. How much time is required? That is nothing but half life. Clear, Nana? So the half life. See, students, now I am taking the equation, zero order reaction. What we calculated, K value R naught minus R by T kada. So this is the integrated rate equation for zero order reaction. Correct? K is equal to R naught minus R by T. Okay, so this value, this is the, which one, students? Is the rate constant of zero order reaction, students. Now this equation I am taking to calculate the half life. Okay, now see, Nana, T is equal to K is equal to R naught minus R by T I am taking. Okay, now we have to find the T half. Now what I am taking, T is equal to how much? T half. That means the time should become T half. To become T half, R naught. Okay now, so see here, it is the initial concentration of the reactant, R is the final concentration of the reactant. Now the final concentration of the reactant should become half of the initial concentration, because to become this is initial is 100, final should be 50%. That means 50% means it is the half of the initial concentration. That means R naught by 2. So these two values here substitute, Nana. Then what you will get, Nana? K is equal to R naught minus R value how much, students? R naught by 2. Okay, divided by T. Now how much, Nana? K is equal to LCM 2 into R naught minus R naught by 2 into T. LCM 2 into R naught minus R naught by 2 into T. Okay, now K is equal to 2 R naught minus R naught how much, students? R naught by 2T. T means how much, students? T half na. Take here T half. Clear this one? 2 into T half. R naught by 2 into T half. But what we have to find? T half value we should find. So that means T half is equal to how much, Nana? R naught by 2K. Okay na, it is R naught by 2K. That means what we can say, T half is nothing but half life for zero order reaction. It depends on the initial concentration of the reactant. Understanding, students? T half depends on the initial concentration of the reactant. So finally we can say that T half depends on the initial concentration of the reactant. Okay na, that means R naught. Understood, students? This is in the case of zero order reaction. So this half life we calculated for the zero order reaction, students. Clear this one? We calculated for zero order reaction. Understood, Amma? So this is about the integrated rate equation for the rate constant of zero order reaction and half life calculation. Clear this one? Now graph I am going to discuss. See, students, T half is equal to how much? R naught by 2K. Now take that formula. T half is equal to R naught by 2K. Now it is in the form of Y is equal to mx. Correct? Now what is Y is equal to mx? Graph, see, students, Y is equal to mx. So y is equal to mx graph, how it will be, Nana? It is passing from the origin, correct? So this is the y is equal to mx graph, students. Now along y-axis, which one is there? T half. That means along y-axis I am taking T half. Along x-axis I am taking x, means here r naught. 1 by 2k is the constant now. R naught is variable. So that's why R naught I am taking. So T half and R naught. What is M value, students? M is slope. How much, Nana? 1 by 2k. So M is equal to 1 by 2k, students. Addaitama. So this is about the graph of half-life, Nana, between the T half and R naught. Clear this one? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, Nana. Thank you very much, students.